Gabriele Bartolini, Director of Second Quadrant Italy and member of the Postgres community. Thanks.
Okay. Thank you. Hello. Good morning, everyone. How are you? Are you all good? Anyone from outside of Italy here? Okay, one person. Good. Where are you from?
Los Angeles.
Los Angeles. Good. Welcome. Okay, how many PostgreSQL users do we have here today? Okay, very good. How many of you are actually thinking of moving away from Postgres? Why?
I'm not satisfied of its capacity and the missing feature of the multi-master replication.
Why do you need multi-master?
Because I need consistency in the cluster, and I want no points of failure, no single points of failure, and the missing management of
Sharding.
the auto-promotion of...
Auto-promotion. Okay, auto-failover. We can talk about it because there's a lot of work that's on the way. So one of the projects that we are working on is called BDR, which is bidirectional replication. And we talk about it briefly. I mean, this talk today, I normally present it on a 45, 50 minutes base. So what I'll do today, I'll basically skim, throughout the presentation. So you will get a lot of features. And then if you have questions, you can stop me afterwards. Okay? So how many of you are actually familiar with the DevOps culture? So is there anyone that would like to get a small introduction about DevOps? Okay, because otherwise we can skip it. Okay, we're talking about PostgreSQL 9.4, which is actually PostgreSQL 23rd. So it's the 23rd version of Postgres. So it's a very mature and robust project. It's probably one of the most stable and successful open source projects ever. When you refer to Postgres, please don't call it Postgre or Post something. Use Postgres if you're not familiar with the term PostgreSQL, which is the official name. And just stick with either of these two terms when you post a message on a PostgreSQL mailing list. Otherwise, your email will end up in the spam folder. So if you want to be considered by the community, use them. About myself, briefly, some important dates. 82, Italy became world champion. In 84, I got my first C64. Then 95, Linux, PostgreSQL in 2000. Then I briefly lived in Australia. And I was one of the founders of the Italian PostgreSQL user group and organizers of the first PG Day conference in Europe. I'm one of the founders, of the 4 founders of PostgreSQL Europe, and also the director now of PostgreSQL, Second Quadrant Italy. And this year I've also founded Second Quadrant Australia. Second Quadrant is the largest group of PostgreSQL experts in the world, and we are renowned leaders in replication, recovery, scalability, and performance. And soon our next book of PostgreSQL administration will come out actually this month. And I'm one of the 4 authors. So our probably top service is the 24/7 support that we deliver in the follow the sun method. So we have 4 centers, and each of them performs a 6-hour shift. So we always work during business days, and we also offer guarantee of resolution and 15-minute response time. So DevOps is a cultural movement that basically, wants to tear down this wall that sits between development and operations. So collaboration, communication, and integration. So we want developers and operations to work together on common goals. That's basically my view of the DevOps movement. So develop software with continuous cooperation between devs and ops in every phase of the process. So what I've done here, okay, if you want to read about the full story, we've wrote several blogs about it, and also there are presentations on this topic available. So we will be briefly going through 9 features classified on a DevOps point of view. So basically, I've selected some features which are more oriented to developers and some others to operations. But then the two compartments have to work together to adopt them in your business and organization. So the first one, we start with developers. So it's the PostgreSQL feature that have been added in the last years in Postgres. And in 9.4, we introduced the JSONB data type. So how many of you actually are using JSONB in production now? So you have 9.4. Okay, 1, 2, 3 people. Okay, good. So in 9.2, the JSON data type was introduced in Postgres, but it was more a string representation of a JSON object. Whereas in 9.4, the binary representation of JSON data type has been introduced in Postgres. So this means better indexing, most importantly, and also better storage. So I'll give you an example. This is actually a benchmark that's been performed by some community members of Postgres that actually shows that PostgreSQL on a single node with JSONB goes faster than MongoDB. Okay, but this is on a single node, obviously. If you need sharding, there are some limitations in Postgres, and but we will get there. But we manage some of the largest PostgreSQL clusters in the world, and they work fine with just one single server. So if you need sharding, okay, in some cases it is useful, but always ask yourself if you need it, okay, before implementing that. This is an example. Before 9.4, we could use a functional index on a JSON data type, so we could exploit a standard B3 index, whereas now we can use gene indexing support. So we created a quite generic gene index on the review column, whereas here we had to be very specific. So index the product category element. This is generic. And this is how we can search for JSON objects and values inside a JSONB data type column. And this is very fast. If you want to know more, Marco Necciarini has written an article about this. It's in our blog. And tomorrow we will be giving a presentation about this topic. So another important feature for developers are materialized views. A materialized view, for those of you who are not familiar with it, is basically a table created from a view. So normally views are interpreted on the fly at runtime, but you can actually materialize the content at a particular moment and store them as a table. So 9.3 introduced the refresh command, and 9.4 the refresh concurrently command. This means that this is an example of view. It's like a data mart. If you operate on data warehouses, this is a very familiar concept. You create this materialized view. You can create indexes on them. And then once a day, for example, you run the refresh concurrently command, which doesn't prevent your readers to access your materialized view while it's being updated. Then we have automatically updatable views that have been introduced in 9.3. 9.4 improves their support. I'll show you how. You can add also other fields, calculated fields that are not updatable. And you can perform insert into, updates, and delete from views if they are compliant to some requirements. Here you can find some examples. Slides are available, and you can, if you're interested in them, you can get more information. Then there have been added some features for aggregations and computations on aggregates, and the filter close. I have to go quick, sorry about it, but this is just to give you an idea of the new things, and then, as I said, you can stop me later. Then two more features for developers: better explain output. You can also get the planning time as well as the execution time. So you have more granularity of results here. And then you have constructors for time values, like make interval and things like that. So let's go to the ops section. It's another step towards multi-master. This version introduces physical replication slots. I don't know how many of you have implemented stream replication. Okay, so you're aware of this setting. Basically, from 9.4, you don't have to worry about it anymore, because replication slots take care of that. So they keep track of all the WAL files needed by each replication client. And it's basically this will introduce logical decoding, which I'll talk about here. Basically, on top of replication slots, we can have logical replication slots. Logical replication slots open a new frontier, basically. With replication slots, you can continuously store events generated on tables. So it's like using a database as a queue for events on records of your tables. So you can create a logical replication slot in a database and then decode events from these slots. It's not an easy concept if you haven't worked with replication, but this example probably will clarify everything. So suppose you have a table, you insert values, and you have logical decoding enabled, and you have a logical replication slot. You can get the changes that PostgreSQL transparently collects on the table. This tells you that transaction 1013 updated table public AA, and these are the fields that have been updated. you can store all the old values and the new values. This means that, for example, you can replicate your changes from Postgres to an Oracle database, to a MySQL database, to another PostgreSQL server. And that's the thing. Logical decoding serves for PostgreSQL bidirectional replication. So collecting all these changes will allow us to use asynchronous multi-master replication, which we have in place on some customers, quite big customers. If you want to know more about the bidirectional replication project, this is the URL you have to look for. Then PG pre-warm has been added, so after a restart, you can fill up your cache of all the pages of a table, for example. So when the PostgreSQL is shut down, when it starts, the cache is empty. So the first time you access a table, it takes a lot of time to get the data from disk. With PG pre-warm, you can speed up these operations. Then there's better table space management. There's a few DDL you can use here for improving, as I said, table space management. Then there's this is my small contribution to PostgreSQL 9.4. I wrote this statistic view in the catalog. It's called pgstat archiver. So basically, if you have a disaster recovery solution with Postgres, these statistics will tell you exactly how the archiving process is working and what its state is. So you can. I wrote a blog article about this. Again, if you want to know more. 9.4 introduces time-delayed standbys. You can have a standby server and say, I want this server to be 8 hours behind the master. This is the first implementation of disaster recovery with replica in Postgres, because replication is not a disaster recovery solution. Okay, replication can serve for load scalability and for high availability, but not for disaster recovery. Because if you delete a table and you have synchronous replication, it's vanished on your standby server as well. So you need a backup. But this will cover you for disaster recovery solutions. You can now change settings on the fly through the alter system command. So this really could improve the ops part of a DevOps environment with Postgres. And that's it. I'm sorry that I couldn't stop on all the features, but if you have questions on any of them, please raise your hands.
Any question?
No questions. Come on. Okay. Yes, please. Otherwise, I'll go over some topics.
Are there any object relational mappers that support JSON-B today? And if not, do you know if there are any on the near-term horizon?
Well, there's PsychoPG2, but I don't know if you may. I don't use ORMs. That's the thing,
Totally fair if it's beyond the scope of what you're talking about. I was just curious.
No. ORMs, JSON-B, as far as I know, only PostgreSQL supports that. So ORMs normally work on minimum common sets for every DBMS. So I don't know if some of you actually can reply with more accuracy to this question. Please.
It will implement it.
Well, Django,
1.8.
yeah, 1.8 I know, but I don't know if it's an ORM,
Sure.
But I know PsychoPG already supports that. There's a lot of cooperation between the Python community and the Postgres community. They're very tied, so it's a good common effort, I would say. So thanks.
Are there other questions?
Maybe I can describe better the multi-master.
You have 4 minutes.
Yeah.
If they had enough.
Yeah, let's go back here. So let's explain better physical replication slots. With basically physical replication slots keep track of the status of the replication process for every client. So if we have 10 clients, 10 standbys, the master now is able to know at what point the replication process is for every client. Okay, this allows us to have a better management of the storage of the master. So on top of these, because now the PostgreSQL server knows exactly knows everything about the process for every server, we can add logical replication slots. So adding a new wall level, which is now logical. Before there were archive, minimal archive, hot standby. Now there's also logical. PostgreSQL stores more information in the wall file. So this information contains all the change sets, logical change sets for every record, or DDL as well. So if you create a table, now this information could be replicated. Okay. And most importantly, physical replication operates on the cluster. Logical replication can operate on a single database. So this is another difference. I don't know how many, have you ever used Sloany, Londist, PGQ? Okay, these are trigger-based replication systems. This technology will supersede trigger-based replication. So that will be wiped out. You will have your changes stored directly in the database, and then through logical decoding, you can grab them. So this is the basic technology that's been introduced in 9.4, mainly by actually Second Quadrant, as part of the BDR project. So our aim is to slowly put the BDR project into Postgres, starting with an extension. So logical decoding represents a big chunk of this multi-year project that's been introduced in Postgres. So thanks to this technology, more servers can operate as masters, and then through logical decoding, communicate to each other the changes that have occurred on servers. So synchronization, of course, will be important, and also conflict resolution. But that's what the BDR project is about. And again, I suggest that if you want, we can talk about it and have a look. We also have an event in Milan, which I want to. It's a free event, and we will be talking about BDR there as well as many other topics. So,
Thank you, Gabriele.
thank you.